Welcome to another video that explains you about the material of 10th grade advanced algebra. And now we are going to discuss about factor theorem. Okay, we have been introduced with the basic or the concept of factor theorem yesterday, but let's just review quickly what we've learned so far. The definitions, I will divide it into two. First, x minus b is a factor of a polynomial px if and only if I put b into that polynomial to replace x, that polynomial will be 0. Okay, for example, if x minus 2 is a factor of this polynomial, x cubed plus 3x squared minus 6x minus 8, if and only if the 0 of this factor, which is 2, if I replace x by 2, that polynomial will be equal to 0. So I put 2 to replace x, 2 cube plus 3 times 2 square minus 6 times 2 minus 8, it will be 0. Okay, you can calculate it by yourself and you will find out it is 0. Therefore, x minus 2 is a factor of this polynomial. So if I use the other kind of example, x plus 5 is a factor of this polynomial, x cubed plus 3x squared minus 18x minus 40. If the 0 of this factor, which is minus 5, if I replace x by minus 5, if and only if, it will be 0, minus 5. I replace it by x. I replace x by minus 5, sorry. So, yeah, this is the first definition is for this kind of factor, as simple as x minus 2, x plus 5, x minus 10, and so forth. But if we have a rational one, okay, rational factor, which is ax minus b, ax minus b is a factor of a polynomial if and only if the 0, which is b over a, of course, if I replace x by b over a, it will be 0. Well, it's just the same, but we'll just have a more complicated factor, that's all. So if I give you the example, 2x plus 1, 2x plus 1 is a factor of this polynomial, which is 2x squared plus 2x cubed plus 3x squared minus x minus 1, if and only if the 0 of this factor, which is negative half, I put negative half to replace x into this polynomial and I calculate it, it will be 0. Okay, so if I have 0 as the values of the polynomials when I replace x by negative half, the 0 of this factor, the value will be 0. Okay, and another example, 2x minus 5 is a factor of this polynomial if and only if when I replace x by the 0 of this factor, which is 5 over 2, look at this, 5 over 2, I replace x by 5 over 2, 5 over 2, 5 over 2. You can calculate it by yourself and yeah, you can use calculator, it will be 0. Okay, these are the definitions. Now this is the application. There will be two different cases that we will discuss. The first one, we factor a polynomial with the coefficient of the highest degree term equals 1. What does it mean? The highest degree term, for example, this is the polynomial that we want to factor. The highest degree is this one, x to the 4th power, the highest degree term. Then the coefficient of this one is 1. Since there is no numbers displayed, well, based on the agreement, it is 1 actually. So this is the first case. If we have 1 as the coefficient of the highest degree term. So if you can refer back to the concept of factor theorem, what we are doing now to find the factors is we try to put some numbers, the candidates first, for example 1, and then we try to put 2 into the x, and then calculate will the polynomial become 0 using that number. So we can use 1, 2, 3, and don't forget we also need to consider the negative ones, -2, -3, and so forth. And don't forget we also may consider the rational numbers, for example half, 3/4, and so forth. There will be many candidates and it will be endless. So there is a tip of how we can limit our search. How can we have a border or like a domain of our candidate, which is refer to the last term, this one, 24. Okay, so for the last term 24, you to put the list what are the factors of 24 including 1. So it is 1 and -1, and then 2 and -2, these are the factors also, 3 and -3, 4 and -4, 5, no, it's not a factor, 6 and -6, yes, you need to consider that, and then 8 and -8, and we need to consider also 12 and -12, and 24 and -24. So actually there is a limit of our candidates to be checked into the x and then calculate whether it will make 0 or not, which is there will be 1, 2, 3, 4, 5, 6, 7, 8, 16. We have 16 candidates. So for these particular problems, we don't have to consider rational numbers, non-integer numbers. Okay, just these 16. So now, this is a good news. We only have to check 16 numbers to find all of the factors. Now I will put it this way. Okay, these are the candidates that we need to consider, which is there are 1, 2, 3, 4, 5, 6, 7, 8. 8 times 2, 16 candidates, because we need to consider both the positive and the negative numbers. So let's begin with this one, +1. So if I use +1 and I put it into this polynomial to replace x, 1 to the 4th power plus 2 times 1 cubed minus 13 times 1 square minus 14 times 1 plus 24, and I calculate it, it will be 0. So 1 is the 0 of the factor that we are looking for. So the conclusion is one of the factor of this polynomial is x minus 1. Don't forget, if the 0 is +1, then the factor is x minus 1. Okay, so we have had the first factor. And of course you will notice that if we have a polynomial with the highest degree of the x is 4, it means there will be maximum 4 factors. Maximum, it can be 4 factors, it can be 3 factors, 2 factors, or maybe only we cannot factor it at all. But let's just open to the possibility that we have 4 factors. So we have found the first factor. Okay, let's proceed. So the next candidate is -1 plus +1, -1. Okay, so if I put -1 into the polynomial, I have the result is 24. So it is not one of the factor. So I need to proceed. How about 2? Okay, go next, +2. +2 I put into the polynomials, I have -24. So it is not also the factor. How about -2? Well, good news, we have another 0. So if the 0 is -2, then the factor is x plus 2. We have the second factor, x plus 2. Okay, again, let's search for the other 2 possible factors. So let's continue with +3. If I use 3, yeah, we are getting here, okay, right? So 1, 2, 3, 4, if we 6, 8, 12, and 24, don't forget. Yeah, 16 trials and error. If we use +3, it's 0. Okay, if I replace it into this polynomial and I calculate, it will be 0. So we have the third factor, which is x minus 3, because we are using 3 to replace x. So let's continue to negative 3, and you see it is negative 24, the result, so it is not one of the factor. If I use positive 4, it's not also 0. So, and if I proceed, oh, we have the last one. So if I use negative 4, the values of your polynomial become 0. So there you go. We have the fourth factor, which is x plus 4. So should we stop there? Yes, of course. We have already had our all of the 4 factors, so you need to stop there. You don't have to proceed with the positive 6, negative 6, positive 8, and so forth. No, we have acquired all of the answer. So if I put the factors here, let me just write it now. Okay, so it will be x minus 1 multiplied by x plus 2 multiplied by x minus 3 multiplied by x plus 4. So yeah, if you factor completely this polynomial, these are your factors. So yeah, this is how you use the factor theorem. And of course, it will be a hard work. And again, it is not necessary you do it orderly. So in this order, no, of course not. Sometimes we have a hunch, right? We have a hunch that we can skip numbers. So maybe at the beginning I use 1, and then I think I have a big I have a, yeah, I know, I noticed that maybe negative 1 is not the case, so I skip calculating negative 1. And then I just try to use negative 4, for example. Yeah, you can pick that. But don't forget, if you choose that, you really rely on your luck, right? Or your intuitive, of course. So it's up to you. You don't have to do it in order. That's the case here. So yes, you can do random, first positive 1, just use your hunch. Maybe after that you go negative 4. So you will have a very good feeling if you are choosing at the beginning 1, and then the second one directly you have a hunch that it will be negative 2, and the third one is, and then you check directly 3 and then negative 4. So only with 4 trials you find already you have found already the 4 factors. So yeah, although it's kind of big luck. So again, this is the factor theorem. This is the first approach that you can use to do trial and error to find the zeros that can be your factors. But there is another approach. If you don't want to use this, all of these, trying one by one, calculating the values, we have the second approach. I will explain to you. So first, use the candidates, and then after I find one of the factor, okay, I stop there first, since I know that it will be equals to x minus 1 multiplied by a polynomial. So I will find first the b, this one, the polynomial of this b, okay, by using the long division. Okay, so let me just use it. So I will divide it. It is x to the 4th power plus 2x cubed minus 13x squared minus 14x plus 24. Okay, and then I will divide it by x minus 1, since this is one of the factors. So let's just use it. X cubed, so it is x to the 4th power minus x cubed. You subtract it, it became 3x cubed minus 13x squared. So I will multiply it by 3x squared. It will be 3x cubed minus 3x squared. You subtract it, it will be negative 10x squared minus 14x. It will be minus 10x. So it will be negative 10x squared plus 10x. When you subtract, it will be negative 24x plus 24. So I will multiply it by negative 24. So it will be 0. So the other factors that we are looking for, let me just change it. It's not b, of course. It will be x cubed plus 3x squared minus 10x minus 24. So the thing is, we need to still factor this one, right? We need to still to factor this one. So how should we factor this? Since it is still a high degree, let's use another factor theorem. Okay, and let's focus it on this polynomial. So let's recall back. if we want to use the factor theorem, let's use this as the reference. So the candidates are still the same. So it is plus minus 1, plus minus 2, plus minus 3, and so forth, plus minus 4, plus minus 6, plus minus 8, plus minus 12, plus minus 24, right? So let's just focus on this one. But I will use, for example, yeah, we have already known that negative 2 is one of the zeros. So let's just pretend that we don't know, and let's use negative 2. But remember, now we want to factor this, okay, not this one. Okay, so because we have already, yeah, you get the idea. So let's put negative 2 into this polynomial since we want to factor this polynomial. So the result will be negative 2 cubed plus 3 times negative 2 squared minus 10 to the multiplied by negative 2 minus 24. So it will be negative 8 plus 12 plus 20 minus 24. So do we have, yeah, we have 0 here. Therefore, negative 2 is one of the factor, which is x plus 2. Okay, since we know x plus 2 is one of the factor, so we can conclude that, let me just erase this. I'm sorry with the, okay, I'm sorry with the mess here. So actually we can say that it will be x minus 1 multiplied by x plus 2 multiplied by, let's just say c, okay, since we have already factored this one, right? So how to find c? Let's divide it again. So I will divide x cubed plus 3x squared minus 10x minus 24, okay, by x plus 2. So it will be, let me just erase this. Okay, sorry with that s, and yeah, so x squared, x cubed plus 2x squared, sounds right, it will be x squared minus 10x, so it is plus 1, plus, I'm sorry, it's x squared plus 2x. When you subtract, it will be negative 12x minus 24, so it is negative 12. Okay, sorry, I'm losing space here. So actually the c is x squared plus x minus 12. So if I put it into this one, it will be x squared, wait, x squared plus x minus 12. Okay, so yeah, I don't know which one is faster. Should we just find trial and error one by one, and then so actually we can factor it completely, since of course we can easily factor this one, right? So it will be x minus 1 multiplied by x plus 2. This one is x plus 4 multiplied by x minus 3. So yeah, this is another approach how to factor this polynomial completely. So with the factor theorem, find the first factor, which is x minus 1, and then you divide it. Okay, you divide it with the long division, and you will have this one as the other factor. But you have a hunch that it still can be factored. So how to factor this one? Use another factor theorem. But the factor theorem, you focus on this part, right? So after I use the factor theorem, I use negative 2, for example, and I put it into this polynomial. I have another 0. So this is another factor, x plus 2. So I write it this way. So the one that being left, x squared, the last factor is x squared plus x minus 12, and I can directly factor it with splitting middle terms on another method. So I can factor completely the polynomial without trial and error for all the candidates and finding the factors. So yeah, you can choose also this one. Or there will be the third approach. Okay, we are using the factor theorem to find the first two factors. So I will just quickly review the steps. I put 1, and then I have the first factor, x minus 1. So I put here x minus 1. And then I continue to search -1. No, it's not. 2, and then -2. I found the second factor, so it is x plus 2. Okay, so because I know there will be like 4 factors maximal, or maybe 3. So the last one, I stop there, and I will use the long division. So first I will divide this by x minus 1, and then the result of that division, I will divide it again with x plus 2, and then I will find the last factor. But instead of I'm using this, okay, so first I just like the previous approach, I will divide 2x cubed minus 13x squared minus 14x plus 24. Okay, I divided by x minus 1. So this is long division. But now I want to teach you about the synthetic division. Okay, this is another method of doing division like this with a simpler way using synthetic division. So how we use synthetic division? First, I put in order because we have the fourth degree. Okay, this is the fourth degree, which is this is a quartic. This is a quartic polynomials. Therefore, I put like 5 position, 5 slots. This belongs to x to the fourth power. This belongs x to the cube, x squared, x, and no x. This is like x to the 0 power. Okay, so just put the coefficient. The coefficient of x to the fourth power is 1. The coefficient of the cube is 2. And this one is negative 13. And the next one is negative 14. And this one is 24. Okay, this is just, I'm just doing the same long division, but in the simpler way. And this one I put the 0 of the divisor because I divided by x minus 1. The 0 is 1. Okay, so this is how you do it. First, this always empty. This one is always empty. And this always like addition. So it is the opposite of long division. Long division, we always have subtraction, and so forth. But this one is addition. That's why if you want to choose one method, try to be good at it and try to memorize it. Plus, so because it is empty, it will be 1. 1 add by empty or nothing, it will be 1. And then when it goes here, you multiply it by the 0. Since the 0 is 1, so 1 multiplied by 1 is 1. So you add 2 by 1, it will be 3. It goes here, you multiply it by 1. So it's 3. Negative 13 plus 3, it is negative 10. It goes here, it will be negative 10. Negative 14 minus 10, it is negative 24. And then it is negative 24, it will be 0. Right? So I'm sorry, let me just put the line here to know which columns that you are dealing with. So this will be always the remainders. Okay? And this will be, so the result will be x cubed, since the coefficient is 1, plus 3x squared minus 10x minus 24. So this is the result of the division. Quite easy, right? So this is how you do the synthetic division. And I will show you, since of course we have already had the result. Let me just erase this one. Okay, please bear with me. So look at our approach now. Okay, don't forget that we want first to divide it because we have already had 2 factors. We divide first all of this with x minus 1, and the result we divide it again by x plus 2, so we can find the last factor, right? So because I want to divide this one by x plus 2 now, okay, let's use another synthetic division. Okay, so wait, it's not a good line. This is a synthetic division. Okay, so I divide this one, don't forget. So it is 1, 3, negative 10, negative 24. Since it is a cubic one, so it's just the slot for x cubed, this is the slot for x squared, this is the slot for x, and this is the slot for no x, just the coefficient, just the numbers, just coefficient, the constant. So because I divided by x minus 2, x plus 2, so the 0 is negative 2. Remember, put the 0. So this is addition. So let's put the empty box here. So 1 plus empty, it's 1. When it goes here, you multiply it by negative 2. Remember, you multiply it by negative 2. So it is negative 2. 3 plus negative 2, it is 1, right? And then when it goes here, you multiply it again with negative 2. Negative 10 minus 2, it is negative 12. Negative 12, when it goes here, you multiply it by negative 2 again. So it is 24. Negative 24 plus 24, it's 0. So this will be the remainders. So the result of this division is x squared. Remember, the result of division, you will take one less degree. For the previous one, we divide x to the 4th power by x, so the result will be a cubic, quartic to cubic. And from cubic, it will be a quadratic. So x squared plus x minus 12. So this is the result of the division. So we can put it x squared plus x minus 12. So from here, we can factor it conveniently with our technique. It will be x plus 4, x minus 3. Done. Okay, so yeah, I have taught you 3 different approach. You can pick any despite, well, it depends on the situation. And I also have taught you about the synthetic division, this one, to replace long division. But if you prefer to do the long division, that's fine, because there is one thing that I want to remind you. For synthetic divisions, it will be safe only if the divisor is a factor with the coefficient of the x is 1, like x minus 1, x plus 2, or x plus 3, or x minus 4. Okay, if the divisor is that kind of factor, it will be safe to do the synthetic division. But if the factor is like 2x plus 1 or 3x minus 5, it will be not suggested. So just don't do that on synthetic division, because there is something that you need to tweak after. So this is just for those who are good in math, okay? And I want you to find it yourself. But again, the safest one is the long division, okay? But I just want to teach you the synthetic division since it can be quicker to be executed. But just notice it's only safe for a divisor like this one, not this, not this, okay? The second case is how to factor a polynomial with the coefficient of the highest degree term is more than 1. So the thing is, we have this one is a cubic, right? This one is a cubic. And the highest degree is this one. But the coefficient is not 1, it is 12. Now we have different case here. Since it is 12, it is more complicated. Okay, if this is 1, we can just need to refer to the last term, and then we can just find all the factors, which is like plus minus 1, this one is plus minus 2, it is plus minus 3, plus minus 4, not 5, plus minus 6, plus minus 10, plus minus 15, plus minus 30. I guess we have covered all. So 4, no, 5, yeah, 6, 8. Yeah, so we need to consider 1, 2, 3, 4, 5, 6, 7, 8. So it's still 16 candidates if the coefficient is 1. But if the coefficient of the highest degree term is 12, there is something more that you need to consider, okay, which is the coefficient of this one first also, which is 12. So you need also to find all the factors for 12. So it is plus minus 1, plus minus 2, plus minus 3, plus minus 4, and then what? Plus minus 6, and plus minus 12. Okay, so the candidate that you need to find, yeah, that you need to check one by one to put it into this polynomial. First one is the factor from the last divided by the factor of the first. Okay, so let me give you example. The first factor that I picked from the last one is plus 1, divided by the first factor of the from the first term. The coefficient of the first term is plus 1, which is 1. So this is the first numbers that I can check. Positive 1, of course. The second candidate will be negative, for example, plus 1 from the last factor, from the last coefficients, divided by negative 1, which is negative 1. Okay, this is the second candidate. The third candidate is I pick plus 1 divided by plus 2. So we have a candidate of a non-integer. That's the problem. So we need to consider half here and put into this polynomial and check whether half can make it 0 or not. Okay, so that's the tricky part. So for example, I can put random. So first I can also, in the next one, I can choose -5, one of the factors of the last coefficient, divided by this one, plus 6. So I still also can consider -5/6. Can you figure out how many candidates we have here? A lot. So yes, if we have this situation, this is really relies on your intuitive, and we need to be quite lucky to easily find all the factors. Okay, so let me just show you how to answer this one. So after you factor out all the possible factors from the last term and the coefficient of the highest degree, okay, let's just let's go to the first candidate. For example, plus 1 divided by plus 1. So it is 1. If I put 1 into these polynomials, I can see that it's not 0. It is -15, so I need to proceed. So the next one, for example, -half. -half is from, this is +1 divided by -2, or -1 divided by +2. Either way, it can be -half, it can be half. For this one, -half, it's still not 0. So you can figure out that there are, we did, this is just a hard work, but let me just go to the answers, which is 2/3. Okay, 2/3 comes from +2 divided by +3, or -2 divided by -3. Either way, we have 2/3, and if I put 2/3 into these polynomials, I can have 0. Therefore, 2/3 is the 0 of the first factor. So the first factor will be 3x minus 2. So how do you find 3x minus 2? Let me just show you how to do it easily. So for example, because 2/3 is the 0, therefore the factor is x minus 2/3, right? And then since we want to get rid of the fraction, I will multiply all by 3. So I have 3x minus 2. So that's how you do it. Okay, so let's continue to the next one. If I have 2/3, let me just erase this one. The next one, after you just use trial and error, or maybe you are using your luck there, you can find out that the next factor that we have is -3/2. Okay, -3/2, which comes from +3 divided by -2, or -3 divided by +2, because when I put it into this polynomial, it will be 0. So the next factor will be, because this is -3/2, the factor is 2x plus 3. Again, let me just show you how, because it is -3/2, therefore the factor is x plus 3/2, and then I multiplied all by 2, so it is 2x plus 3. Okay, so that's how you do it. So yeah, just the same, because this is cubic, of course the maximum factors will be 3. So it can be 3, it can be less than 3, but for this one it is 3, and this is the last one. 5/2, so it can be derived from +5 divided by +2, or -5 divided by -2. Again, this, I just want to give you the answers, but obviously we cannot just directly find all of these 3, of course. So we need to expand our search to like +3 divided by +6, or +3 divided by +4, or -3 divided by -4, and so forth. Okay, but of course, for example, +1 divided by +1 is 1, and +3 divided by +3 is also 1. So yeah, of course, you notice that you don't have to check another 1 into the polynomials, right? We have already searched for 1, so skip it. Okay, or for example, we have already searched negative half here. Therefore, you can skip if you find negative 3 divided by positive 6, which is negative half also. So just skip it. Okay. Yeah, of course we can also narrow our search, but still it's just an extra work. It's hard work. So yeah, after you find all of this, we can conclude that the factor of this polynomial will be 3x minus 2 multiplied by 2x plus 3 multiplied by 2x minus 5. And don't forget that this one, I use the first approach, which is finding one by one using all factor theorem. But of course, you can also use the second approach, which you divide after you find the first one, the first factor, you divide the polynomial with this, and then you find the result, and you can factor it conventionally. So yeah, it's the same with the first case, but the difference is just that the candidates are more complicated, right? So be careful. We have two cases. The first one, the coefficient of the highest degree is 1, and the second one, the coefficient of the highest degree is more than 1. Give me 12. Be careful. And the last section here, I just want to give you a brief explanations about how to factor the sum of two powers with equal exponents, but only for odd numbers. The sum and difference. You have already been familiar with the sum of two cubes, right? If this is the case, the factor will be x plus y multiplied by x squared minus xy plus y squared. If I have the difference of two cubes, the factor will be x minus y multiplied by x squared plus xy plus y squared. But actually, we can do the same thing with distinctive patterns if we have the sum of two powers with equal exponents, but only for odd numbers. So for example, x to the fifth power plus y to the fifth power equal exponents, 5 and 5. So the factor will be, look at the patterns, relate with this one. Okay, x plus y begins with x plus y because we have additions, but the rest will be begins with x to the fourth power. This one begins with x squared. See, because the sum is x cubed plus y cubed, so it begins with x squared, which is 3 minus 1. So because this is x to the fifth power plus y to the fifth power, it begins from x to the fourth power. And then the pattern will be subtraction, addition, subtraction, addition. Okay, and it begins with x to the fourth power, continues with x to the third power, decreasing 1 degree, okay, one by one. And about the y, it's the opposite from this one. It begins with y to the 0 power, y to the first power, y to the second power, third power, until fourth power. See the pattern? The first term, it begins from the fourth degree. The degree is 4 degree, and then decreasing one by one. But the y, the second term, it's increasing. But don't forget about the sign. So actually it's related with this, because this is x cubed, so it begins with x squared, and then continue with x to the first power, and then end with x to the 0 power. But about the y begins with the y to the 0 power, y to the first power, y to the second power. Subtraction, addition. And how about the difference of x to the fifth power minus y to the fifth power? So it begins with x minus y, the same with this. But the cool thing is the second factor, all additions. So this is easier. All addition, but the pattern is the same. X begins from the fourth power, third power, second power, the first power, and 0 power. And the same with the y. Y from 0, y to the first power, y squared, y cubed, and y to the fourth power. So in the extreme way, if we use x to the 11th power plus y to the 11th power, again, only for odd numbers, not even numbers. So we begin with x plus y first, and see the pattern here: subtraction, addition, subtraction, addition, subtraction, addition, subtraction, addition, subtraction, addition. It begins with subtraction, addition, subtraction, addition, subtraction, addition. Okay, and the x begins with the 10th power, since it is 11 minus 1, and then it's decreasing one by one. 7, 6, 5, 4, 3, 2, 1, 0. And for the y, it's increasing from 0, 1, 2, 3, 4, 5. And the the best thing is there is no coefficient, so it's very easy to memorize. So the last one, if I show you the difference of x 11th to the 11th power minus y to the 11th power, it is much easier. It begins with x minus y first, and the second factor is all additions with the same pattern of how the x and y exponents work. So Yeah, you can figure out how to, with the x to the 7th power minus y to the 7th power, as long as it is equals, you can factor it with the same pattern. So that's all about factor theorem and factoring of this specific kind of uh, sum or difference of two powers with equal exponents but only odd numbers. Hopefully it's helped.